today is box plots, exercise 1G. So to be able to calculate or draw a box plot, first of all you need to do what is called the 5 summary statistics. So what that is, you need to be able to calculate the minimum value, Q1, median, Q3 and maximum value. So what I'd like you to do on your graphics calculator is to load this Class A results in here. So perhaps pause the video while you do that, and then what I'm going to do is show you on the graphics calculator how to load the data. So we've done quite a few before. So to load new data, Control I if you need a new page, and select number 4, which is lists and spreadsheets. Then you go up to the top, which is where your heading is, and you type in Class A or your abbreviation for it, and then tab down, and then tab down to number 1, and then load the first result in. So I'll give you a moment to do that. I'm just going to go back to, I've already loaded the results here, so you should have this similar here. So I've called mine Class A. So once you've done that, you need to calculate the 5 summary statistics. So if you've already got a calculator page open, you can open that page, or if you need to do a new one, reminder again that you go Control I, number 1, and do a calculator page. So to call up the 5 summary statistics, so the median, Q1, median, Q3 and maximum value, if you go menu, 6 for statistics, 1 for calculations, and number 1 again for one variable statistics, we have one list of results we want to work out, and if you select Class A, then your results will come up. So you can see here we've got our minimum value being 22, Q1 being 23, 25.5, etc., etc. So if we go back to our notes, you should have all these results on your calculator. Okay, so the minimum, Q1, median, Q3 and maximum value. So before we draw a box plot, and before I show you how to do it on your graphics calculator, what you also need to know is one other thing, and it's called the upper and lower limit. So what we're looking at here is for values that are outliers, and the formula that we have for that is the one that's here on the screen. So for the lower limit, our formula is our Q1 value minus 1.5 times the interquartile range, and our upper limit is our Q3 value plus 1.5 times the interquartile range. So from our example that you can see up above here, the numbers are going to be Q1 is 25.5, and then what we're going to do is we're going to subtract 1.5 times the interquartile range. So I've just written down the interquartile range here for you as being 38 minus 25.5. So when you solve that on your calculator, you get an answer of 6.75. So what that means is if we have any values in Class A that are less than 6.75, they're classified as outliers. And if we have a look at our values up here, our smallest value is 22. So we have no outliers on that lower limit. And what we need to do is do the same for our upper limit as well. So our formula is Q3, which is 38, plus 1.5 times the interquartile range. So when you type that into your calculator, you should get an answer of 56.75. So what does it mean? It means if we have values that are bigger than 56.75, so if we round it up to 57, then it would be classified as an outlier. And if we have a look at our results up here, our largest one is 48. So we don't have any outliers on either the lower side or the upper side. So now what we need to have a look at is to actually draw the box plot. So what you need to do is have a grid, okay, or at least draw a line, and you need to have on your scale down the bottom here, you need to have the smallest value. So in our case it's 22, and your scale needs to count up in equal amounts. So I've counted each line actually represents 1, so I've got 22, 23, 24, etc., etc. If you have a look here, I've gone up to 48 because our maximum value from our calculator says it's 48. So that's what our scale across the bottom needs to be, including the smallest value and up to the largest value. So once you've drawn that scale in, what you need to do is mark in each of the values. So probably yours will be a little bit neater than mine, but where each of the points are, just mark it with a cross up here. Okay, so 22, 25.5 is going to be halfway between, so it's going to be here. Then 33, mark it with a cross. 38, which is where Q3 is. And then our maximum value is here up at 48. And then what you need to do is grab a ruler. So on mine, I'm just going to draw it as a straight line. So between the minimum value and Q1, you draw a straight line with your ruler. And then you do the same from your Q3 to your maximum value, is grab your ruler and join a line that joins both of those up. So these are what we call whiskers, or our upper and lower values. Then what we're going to do is in between Q1 and Q3, we form a rectangular box. So I'm going to draw it here. And the other side as well. Okay, so draw a rectangle. Same down the bottom. Okay, and obviously it's a bit easier with just pen and paper. And then what you do is you draw a vertical line where your median value is. Okay, so what do we have? We've got our Q1 down the bottom here at 22. Then we've got our minimum value down the bottom here at 22. Then we have, so that's our minimum. Then we have Q1 as being the first point here. Then we have our median as being 33. Then we have Q3 as the upper value there of the box. And then we have our maximum value. So that's how you draw a box plot. You don't have to label min, Q1, median, Q3, maximum, but I've labelled it here so you know what the box plot looks like. It is important to have one other thing as well. So we have an appropriate scale. We have each of the values marked in and the box plot drawn. You also need to label your scale as well. So our label is going to be Class A results as well. So that just means that if anyone's reading the graph of the box plot, they can see it as well. So we've drawn our box plot, and hopefully you'll pause this and draw your own in your book as well. Then what we need to do is the last step is interpret the box plot. So the way that we interpret a box plot is we look at the shape, we talk about the center, and we talk about spread. Now, center and spread we've spoken a fair bit about. So the center, we're going to talk about the median, and the spread you'll either talk about the interquartile range, which is that Q1 and Q3 value, or we'll talk about the range, which is just maximum minus minimum. So if we're looking at interpreting box plots in relation to shape, we've got three different types that we can explain it as. So our first one here that we're looking at is, it's known as being a symmetrical box plot. So you can see that we have a median here which is sitting at 15, and the length from the median to the minimum value, so this bit here, is approximately the same as the distance from the maximum value to the median as well. Okay, so if you're chopping the data in the middle at the median, you can see that both sides are approximately the same. Okay, the distance from the median to Q1 and to median to Q3 and Q3 to the maximum value can change a little bit, but basically the length here is approximately the same as the length here if our data is symmetrical. Okay. The other thing that we have is we can have skewed data. So the first one we have, similar to when we drew histograms, is that we have positively skewed. So what it means is the median is usually on the lower part, okay, as we can see here, and the top side, so this half here, okay, because remember the median is measuring to the center, this top half here, you can see, is a much longer than the bottom half of results. So in our lower half, so from our minimum value to the median, the data is a lot closer together than it is on the right hand side. Okay, so this is positively skewed. It's stretched out on the higher side. Okay, often we talk about this whisker. So the right hand whisker will be longer, reflecting that the data tapers off to the right. What that means is it's just that this bit here, so the length from Q3 to the maximum value, tends to be longer than this lower quarter here, so from the min to Q1. The other one that we have is negatively skewed, and obviously it's just the opposite of positively skewed. So typically the median is on the higher half of our results, like it's sitting higher on the box plot, and you'll see that the left hand whisker, so this one here, okay, typically is longer than the whisker on the right hand side. So the distance from Q3 to the maximum value typically is smaller than the distance from Q1 to the minimum value. So that's all the notes for today to go through how to draw a box plot and interpret it. Obviously, if you've got any questions, we'll go through them in class next time. Thanks, girls.